Yep. Once again, very good morning and thanks for joining. Okay. In continues to yesterday, we discussed about DBMS, RDBMS, database systems, and we discussed about a little about language, SQL language, and we started the SQL architecture. Okay. To recap again, the same thing, whatever we discussed. In addition to that, we are going to discuss somewhat very interesting concept. That's the reason we made some flowchart to understand easily what is happening. Okay, rather than telling more theoretical, let's show you something in a different way so that you can understand. See, basically, whenever you are going to perform any operation, that can be data load. See, means insert, update, delete, or the loading the data. Select is nothing but reading the data. Okay, just you are reading the data like bank statement, credit card statement, electricity bill, water bill. These are reading. Okay, so when you are reading, that is a select statement. When you are loading, it can be insert, it can be update, it can be delete, it can be create, it can be alter. Anything you are doing the modification. Globally, we'll do only two operations, either modification or reading the data. So either vice versa, whatever you are doing, how SQL Server internally is working. That's what first we need to understand. So first, as I told you yesterday also, okay, so SQL Server will follow client and server architecture. This is the client and this is server. This is a client, okay, this is a client and this is the server where your client is performing certain operations and server is going to process your request. Okay, server will accept the request, server will process the request, server will send the result to the requester. Vice versa, it will do so. So whenever you are performing, it can be read, it can be write. First, our constant will be read, then our constant will be write. Okay, so first try to understand the read, then we'll again go for the write. So first, it will go to the operating system as usually where your SQL is sitting. It will go to that operating system. On that, via SNA protocol like a SQL Server Network Interface Protocol. It can be shared memory. It can be named pipes. It can be TCP/IP protocol. Using this any one of this protocol, okay, it can be shared memory. It can be named pipes. It can be TCP/IP. Using any one of this protocol, SQL Server will your request will try to connect to the engine. You will try to connect with the engine. So once it pass everything, see, credentials are very important, logins are very important. Everything is very important. So we are not going that much deeper. Imagine everything is good. Whenever you are trying to connect to the engine, first it will pass via network protocol because entire your SQL Server architecture is divided into three different layers. One is a network, one is engine, one is SQL OS. So first it will cross the network layer. Either it can authenticate using shared memory or TCP/IP protocol. It can be used anyone, either shared memory or TCP/IP. Yesterday what we discussed, shared memory is nothing but within the same server. See, in my laptop, there is a SQL is running currently. In my laptop, my SQL engine is running currently. See, when I open configuration manager, I can see my SQL is running here. One instance is running here. Okay, one instance is running here. So within this my laptop, I'm having a server, and SSM is my client. I connected to the SQL Server via SSMS. So within the client and server, both are in the same server. Then by default, it will interact with shared memory. Okay, by default, it will interact with shared memory. In case you are connecting SQL Server remotely, okay, SQL is installed somewhere and you are connecting somewhere. If you install SQL somewhere and you are connecting somewhere, then by default SQL Server will use the TCP/IP protocol. By default SQL Server will use the TCP/IP protocol. Okay, TCP/IP protocol. By default, see, if you are trying to connect to the SQL Server remotely, try to understand the logics are very important. Whenever you are trying to connect SQL Server remotely, okay, you need to protect that connection. See, locally there is no problem because within the same server, you are accessing, you are processing everything, there is no problem. But whenever you are trying to connect SQL Server remotely, then the problem will start because hackers can easily hack your connections, your data. They can mislead easily. To protect that one, while you were trying to connect SQL Server remotely, then Microsoft came up with the concept called port number. One second, sir. Okay. So, for example, now see, now I'm in the local server. My SQL is running on the local server. My SSM is also on the local server, same server, within the same server. Now, if I disable TCP/IP protocol, okay, I'm disabling the TCP/IP protocol. See, if you make any configuration changes, you need to restart the SQL services. Okay, try to restart the SQL services. Okay, again, I'm telling, if you make any configuration changes, we need to restart SQL services so that feature will affect. Otherwise, no, sir. Okay, so don't think that it will affect. Okay, if you simply disable it, it will affect. No, until you need to restart the SQL services. So once you restart the SQL services, then automatically whatever you done, that feature will be affected. Now see, I disable the TCP/IP protocol, and currently by default named pipes will also be disabled. Only shared memory is currently running. So now when I try to connect to the SQL Server, I can do better. Services.ms. So go to the services.ms a little faster, sir. Okay, whenever you are restarting. Sometimes our SQL Server configuration manages little slowly. Okay, I think, yeah, done. It's restarted. Now see, I am disconnecting. Again, I'm connecting. Okay, let me refresh her once just for safety purpose. Okay, now I am trying to connect to the SQL Server. See, now you are able to access the SQL Server because you are in the same server. Your engine is on same server. You open SSMS also. You open the client also same server. Then by default it will use the shared memory protocol. By default it will use the shared memory protocol because TCP/IP is disabled, named pipes is already disabled, and there is only shared memory. Subbu, if if I disable the shared memory also, okay, I am disabling shared. See, all the protocols has been disabled. Now try to restart the SQL once again, sir. Okay, try to restart. See, try to restart from services.ms is a little faster when you compare with the configuration manager. Okay, okay, done. See, now currently your SQL is not coming online. Forget about connection, sir. Forget about connection. Your SQL went down completely. If you disable all the protocols, SQL services itself will go into the stopper state. We don't know why SQL is got stopped. Okay, we don't know why SQL got stopped. Now, better first thing what you need, being you are learning first time, you don't know where I need to check, how I need to check. So first thing what you need to do, open the configuration manager, SQL Server configuration manager. Okay, open the SQL Server configuration manager and go to the SQL services. Oh, you currently with SQL is in stopper state. Try to start it. Definitely will be stopper state only because we disable all the protocols. Now double click on the SQL services. Okay, go to the startup parameters. So I will discuss all this stuff in the upcoming classes also, but just for your reference purpose, I'm showing. There is a error log location, sir. See, -e for error log. Why your SQL is not starting? Definitely SQL Server write in the SQL Server error log. Now copy that error log. Okay, and what you can do, open CMD. Okay, just open CMD command prompt, type notepad. Okay, and paste it. Enter. See, it will. there will be permissions issue. Come on. Only when my laptops are not your laptop, you won't face any such kind of issues on your laptop, because I am doing much more stuff, right? So that's the reason my permissions or somewhere it is missing. Okay. So for you, it will work definitely. Open the log file, see there is a permission issue. Okay. Now open the current error log. Open in the notepad. Now you will get complete information why your SQL is not starting. See, could not start the network library because internal error with the network library. Okay, something it is related to the network. So it is writing some information in the SQL error log. It is writing some information into the SQL error log. Why your SQL is not starting. In case whenever you are trying to connect to the SQL server, see, when you try to connect to the SQL server, definitely it will throw an error. The network library failure, it will throw an error. Okay, because your SQL is currently down. So at least one network protocol you need to enable. It can be shared memory, it can be TCP/IP. Okay, you should enable. Named pipes again, sir, it's as part of SQL hardening, we won't enable. Only focus on the shared memory or named TCP/IP protocol. So when you will go for TCP/IP protocol, when you are accessing SQL Server remotely, see, the network related errors or instance specified error occurs while establishing the connectivity. So you can't connect to the SQL Server because you disable all the firewalls. So all the protocols. Now again, so before that, let's enable TCP/IP protocols. Okay. Then try to start the SQL services. Now definitely it will start the SQL services. See, immediately without any delay, it started the SQL services. So at least one protocol need to run. That can be shared memory or it can be TCP/IP protocol. Now if I connect, now see, okay, are you able to connect to the SQL server? Are you able to connect to the SQL server? So cancel. Okay, cancel. Let's try to connect freshly. So make sure that shared memory need to be enabled. Make sure that shared memory need to enable. So please, sir, so don't disable any protocol, but shared memory is using locally. TCP/IP protocol is using remotely to secure to remote connection. Microsoft, what is doing? Microsoft is setting the port number for TCP/IP protocol. Microsoft is setting a port number for TCP/IP protocol. If I go to the properties, okay, if I go to the IP address, see, there is a port number. You can change that port number. Okay, so by default, not in my system, sir, by default, SQL Server will listen 1433 port number by default. Whenever you install SQL Server first time over the mission, by default SQL Server will listen 1433 port number. 1433 port number by default. So please make a note on this is something very important. Why Subbu is being you are connecting remotely, you are transferring data remotely to protect your connections, to protect our data. So Microsoft is protecting via port number. So what is a port number? 1433 is the default port number for SQL Server. Like if I go to the Postgres, 5432 is the port number. If I go for SQL, 1433 is the port number. So majority of the stuff they will listen to the port numbers. Like if I go for Jenkins, 8080 is the port number. If I go for SSRS, 445 is the port number. 80 is the port number. Okay. So we are having different port numbers, but as part of SQL, our default port number is 1433. Why Subbu SQL is listening 1433 means being you are connecting SQL Server remotely to protect our authentication, to protect our connections. Microsoft is came up with a port number called 1433. Without this port number, you can't authenticate. Without this port number, you can't authenticate. Being you are connecting locally, you can access everything. But if you are connecting remotely, you need to allow the port number. Without port number, you can't connect to the SQL Server. So when we discussing infrastructure level, that time I will show you, sir, all this stuff. Okay. Is it clear, everyone? First thing? No? Yes?
Yes, sir.
Yes. Okay. Now let's back to our side. Okay. Once your connection is established. Okay. Once your connection is established. SNI. Okay. Net. SNI protocol. Why SNI protocol? It is directly connecting to the relational engine. This is your relational engine. This is our storage engine, correct? Everyone, yes or no? So let's write that one also, so better for your understanding. Let's bring here, this is our relational engine. Relational engine. Okay, let's write. It's a relational engine. Now it's a storage engine. Storage engine. Okay. First, it is connecting to the relational engine. So yesterday you remember under relational engine, so we are having command parser, query optimizer, query executor. Try to understand crystal clearly, sir. Okay. This is something very interesting and very important. Everyone must and should know. First, it will go to the relational engine. See, database engine is our core component. Database engine is our core component. Why agent is not started? Oh, wait. Let me refresh. Agent service. Okay. Please don't mute. Okay. Now see, once it connect to the database engine, under the database engine, there is a two engines. One is a relational engine, one is a storage engine. One is relational, one is a storage. So first it will go to the relational engine where there is no data. Make a note down. Under relational engine, there is no data. It is just processing your query. Relational engine is processing your query apart from nothing else it is doing. Apart from nothing else it is doing, sir. Please make a note down. So first it will go to the relational engine. Under relational engine, it will go to the command parser. And what it will do, as we discussed yesterday, first it will check the syntaxes. Agree, not agree, everyone? That's what right yesterday
Yes.
we've been discussed. 1 second, sir. Yeah. First it will check the syntaxes. Okay. Let me show you again once again, sir. It will go to the current database. So first what it will do, it will check the syntaxes, whether you written valid syntax from class, where class, order by class, select statement. It can be insert or update or delete or create or alter or drop or truncate, whatever it may be. Whatever the query you are going to return, that query is properly syntax or not. So it will check first syntax. Once it check the syntax, next it will do the semantic checks. Next it will do the semantic checks. As part of the semantic checks, what it will do, whether the table is available or not, whether the object is available or not, whether the column is available or not. So it will try to validate the object, tables, whatever you written, whether everything is available or not. So if you want to check externally, FMT only you need to see, you need to run at a time. So can I run this one individually? Later on, I can run this one. No, you can't. You need to run at a time. So copy everything at a time and execute. So invalid object name. See, when you go to parse, it will show your parse is fine. Under the parse, it is not checking whether table is available, columns are available, everything is perfect or not. No, it is not checking under parsing. Under parsing, it is just checking the syntax. Under once it successfully syntax checks is fine, then it will do the semantic checks. Under semantic checks only, it is validating table is existing or not, columns are existing or not, everything it will check. Once these two phases successful, then optimizer will start preparing the query tree. Optimizer will start preparing the query tree. Okay. So how query tree looks like? This is how your query tree looks like. Okay. So I will discuss little more stuff in advanced level. As of now, This is how your query tree looks like. First, what it is doing, first it is getting the table details. Okay, whatever the table you are calling, first it is getting the table details. What table you are calling? Sales order details. See, sales order details. Next, it is getting the column details. So it will get the table details, it will get the column details, and you are writing any expressions, aggregations, calculations. It will do all the expressions, aggregation, calculations, everything where SQL can understand. So it is converting high level language to low level language. Once your query tree is prepared, this query tree will be stored under the cache. This is what I not discussed yesterday, sir. Okay, cache is nothing but your RAM. Cache is nothing but your RAM, sir. Memory. Okay, memory. So once your query tree is prepared, that query tree also storing in the cache for the future reference purpose. See, here you are running only one time, sir. In the real world, users application team will run same query in multiple times. Maybe they are running daily basis. Maybe they are running by hourly basis. Maybe they are running every 6 hours or every 12 hours. We don't know when they are running, how they are running. We are not that person to look into that stuff. Somehow application team is rerunning the queries multiple times. Okay, so every time it need to prepare the query, right? It will take some time also to save that time. What SQL is doing, whenever the query tree is prepared, so once the syntax is done, semantic check is done. Once the query tree is prepared, that query tree will be stored as a temporary in the cache, in the buffer. Okay, this is completely buffer. Okay, in the buffer it is storing. In the buffer it is storing. How I can check that information, Shubham, is directly you can't check it, sir, but select star from, okay, sales, not sales, sys dot dm underscore os underscore memory underscore class. Okay, these are all concepts we'll talk in the memory troubleshooting, sir. As of now, no need to worry. Just to explain, Castor. Yeah. Okay, Castor PHDR. This is the clock. See, boundaries. So this is the clock which is capturing your query tree information. This is the clock which is capturing your query tree information. Means once your query successfully passed the syntax checks, semantic checks, and it converted to low-level language, means it prepared the query tree. That query tree information is storing in the Castor PHDR clock. Got it? Everyone? No? Yes?
Yes.
Yes. Okay, don't go too much depth, sir, please. Okay, there is a dedicated session on the memory. I will talk about the clerks. I will tune the clerks. That time you will become strong. As of now, instead of theoretical understanding, I'm explaining little practical way so that you can easily remember. Okay, now what you learn? Okay, once your syntax checks, semantic checks is done, once the SQL Server will prepare the query tree, that query tree will be stored in the memory. As of now, just remember in the memory. Under the memory, where it is storing? Under this clock. Under this clock, it is storing. Castor PHDR clock, your query store information is storing. Okay, your query store information is storing. See, this much size is consumed, almost means 22 MB of size is consumed by the query stores, query trees. How much size it consumed? Page size, page kilobytes. Okay, it's a bytes, it's a MBs. Okay, kilobytes, MBs. 22 MB is consumed by the query trees in the memory. Okay, so it's a small size only. I'm having almost 16 GB of RAM. 22 MB is a very small, sir. Query tree won't consume that much. Okay, so this is the one point you need to remember. Now, once the query tree is prepared, that query tree will go to the optimizer. Imagine he's running the select statement once again, sir. Maybe after 1 hour or 2 hours, he's running. That time again, a command parser won't prepare the query tree. It will verify in the Castor PHDR Is there any query store for that query tree? Is there any query tree in the cache store PHDR available? It will get the query tree, same query tree. Okay, it won't prepare every time. So to save our time, it's not preparing. It is making in the cache. Okay, to explain you what you mean by cache, you will go to the bank. Every bank having the main locker. At the evening, 4 o'clock, 5 o'clock, they will keep everything into the main locker and they will close the doors. And there will be caches in the wherever you go to the department to deposit your account amount or withdraw the amount, they will maintain the temporary caches. So in the morning, early once they starting the office, they will bring the amount from the main locker and they will keep in the cache, and they will process that amount whole that day. Again at the evening, again they will take that cache and put it in the main locker. Like same here also, sir. This is a cache. This is the physical. This is your disk. This is your cache. Memory is a cache. Got it, everyone? Yes, to understand easily. Now, query optimizer. Once your command parser prepared the query tree, your query tree will go to the query optimizer. This is heart for entire your database engine, sir. Entire your database engine, query optimizer is the heart, because which is preparing the execution plan. Which is preparing the execution plan. Every query, what SQL Server will do, SQL Server will prepare the execution plan. This is how your execution plan looks like. It will prepare the execution plan. Technically, we'll call it as operators. Okay, technically we'll call it as operators. Technically, you'll call it as a data flow. From this operator to this operator, how much data flow it is happening, it is indicating via this arrow marks. You will see thin arrow, thick arrow, very large arrows. So whenever you see the thin arrow means your data flow between this operator to this operator is very small. If you see little thick operator, data flow is little massive. If you use larger arrow, then maybe too much data is transferring from this operator to that operator. So you have a lot of parameters, sir. We'll talk about all this in terms of execution plan. There will be 2 days we are spending only on the execution plan. What operators you will see more frequently, how to investigate this operator. If you see that operator, how we need to think, how to resolve that operator. We'll talk that much level, sir. In the query tuning, we are spending 1 week of time for this only, basically. So optimizer will prepare the execution plan for this query tree. Based on what conditions it will prepare means, one is the selectivity, one is the cost. Optimizer is a cost based. So one is the selectivity, one is the cost. Very, very important. So two concepts are very, very important. So as of now, just remember, optimizer will prepare the execution plan. Once it prepared the execution plan, it will store in the plan cache. There is a plan cache. It will store that plan in the plan cache for time being. For time being, it will store the plan in the plan cache. It will store the plan in the plan cache. So this is very, very important. Once your plan is prepared, that plan will be stored in the plan cache for a time being. For a time being, it will store plan in the plan cache. How I can read that plan cache, Shubham, is there is one more DMV. There is one more DMV. That is nothing but, okay, select star from, okay, sys dot dm underscore, okay, exec underscore, query underscore, okay, plan. There is a, this is not a DMV, sir. This is a function. See, whenever you place a cursor, it is showing it is a function. Basically, it is not a DMV. See, if you DMV means I can dynamic management view, sir. I can directly execute it. I can get the details. But this is not a DMV. This is a function. Means you must and should pass the parameter. You must and should pass the parameter. So how I can pass the parameter means select star from sys dot dm underscore os underscore, not os, exec underscore, exec underscore, query underscore, statistics. When I run this query, there is a plan handler. There is a plan, execution plan handler. That handler you need to copy and you need to paste here. Okay, you need to copy and you need to paste here. See, this whenever you run for that handler, it will provide the execution plan. See, it will provide the execution plan. This is what your execution plan. See, for that plan handler, it is providing the execution plan. So where this plan is storing, this plan is storing for temporary in the plan cache. Over the plan cache, that plan is storing. So once your optimizer prepared the execution plan, that plan will be stored in the plan cache. So how I can get the details, Subhum, is this is how you can get the details. So directly you can't get the plan details. Now what you need to do, you need to go to the dm underscore exec underscore query underscore stats to get the plan details. Then that plan ID you need to pass here. Whenever you run, you will get the execution plan of that query. Okay, just remember, sir, no need to think too much here. Okay, again, I will get back all these concepts. Is it clear? No? Yes?
Subbu, I have one doubt.
Yes.
How do we know like exactly what query we run and
we
what?
will get the SQL handle also, sir. SQL handle. There is a query. You need to get here. Again, you need. There is one more. See, that's the one thing. This is only we'll try and in advanced level. Okay. So you need to get one more DMF. DM underscore exec underscore SQL underscore text. Under SQL underscore text, we are getting the SQL handler. For this SQL handler, for this SQL planner, we are getting the execution plan. Got it? Yes? No? Okay. So how many times you executed? What is the CPU time? Okay, you will get everything, sir. How many logical reads, physical reads, massive stuff. You will get it from the internal DMVs. Okay, you will get massive stuff. So as of now, being you are in the learning phase, I am showing you how to see the execution plan. Okay, how the plan is storing, where the plan is storing is, see, when I run to the clocks, see, clocks are very, very important. Under the memory, clocks are very, very important. So that's the reason I'm always running clocks only. So when you go to the, see, almost we are having 431 clocks in SQL Server. How many clocks you are going to learn means top 5 to 10 only, sir. Top 5 to 10. No one knows what these clocks are doing. No one knows, honestly. Don't trust if everyone will tell anyone coming to and saying that I will try 431 clocks. No, sir. Okay. Our understanding should be who is the top consumer. Means when you go to the clocks only, you will get that information. So as I told you, your query tree is going to store in the PHDR clock. Your execution plan, whenever you are running the query, this query execution plan will be stored in these two clocks. Cache store SQL CP, cache store object CP. Why, Subbu, there are two clocks means one is stored procedures. So whenever you go to the any database, there is a stored procedures, functions, triggers. So these execution plans will be stored in the SQL CP. Okay. These are all the ad hoc requests. Only one time you are running ad hoc request. So technically we'll call it as ad hoc request. These ad hoc requests will be stored in the object CP. Okay. But if I want to go to verify, this is how you'll verify. In a technical layman terms, what we are saying, entire your execution plans will be stored in the plan cache. In this plan cache, where it is storing, if someone will ask you this question, in the plan cache, okay, I can understand in the plan cache only. Under this plan cache, where it is storing means, you can answer them, oh, cache store object CP, cache store SQL CP, cache store PHDR. These are the three important clocks. which are going to store your query tree information, which are going to store your execution plan information. Externally, it's a plan cache only. If someone is asking, just tell that where your plans are storing in the plan cache. In the plan cache, that's it. You don't need to tell Castor SQL, Castor BHDR, Castor SQL CP, Castor Object CP. You don't need to tell that one to the interviewer, sir. Just for your understanding, I'm saying these are all okay. But technically, how you need to explain? Once your execution plan is prepared, that execution plan will be stored in the plan cache. That execution plan will be stored in the plan cache. Why Subbu is, imagine next time when user is running again this select statement, okay, your command parser is preparing the query tree, right? Or it is already checking the query tree. For that query tree, there is already plan is prepared. That plan is already stored in the plan cache. So internally, it is going and identifying any query tree is available. That statement, yes. For that query tree, any plan is available, yes. Now retrieve that. It no need to prepare every time, sir. So to avoid that recurringly preparing, you are storing in the cache for a time being. How long it will store means until there is a memory pressure, we won't truncate it. Means we won't delete it, sir. Let it be keep in the cache only. Is it clear? Not clear? Everyone, sir, please.
Yes.
Everyone. Understood? Not understood? How internally, step by step, we are explaining. Okay? Internally, query is processing. So once your execution plan is prepared and stored in the plan cache, now that execution plan will go to the query executor. Okay, query executor will start executing that plan. Will start executing plan. But there is no data in the relational engine. There is no data in the relational engine. Now executor will need to send to the storage engine to process the data. So what it is doing? First, under the storage engine, there is an access method. Under the storage engine, there is an access method. So please make a note on, there is an access method. So access method contains multiple APIs, application programming interface, where it can understand easily, sir. You can't understand, but SQL can understand. How executor is interacting to the storage engine means via ODBC drivers, not OLDB drivers, ODBC, sorry. ODBC drivers. Okay, like see, whenever you install SQL Server, you will get the drivers, ODBC drivers. See, internally, by default, you will get the ODBC drivers whenever you install the SQL servers. So using these drivers, okay, your relational engine is going to talk to the storage engine. That too, it is talking to the access method. Okay, got it? ODBC is a driver. It's a drivers. See, your laptop is also having the drivers. So don't think that what you mean by drivers, Subbu. Even your laptop also, if your laptop want to work very smoothly in terms of audio, in terms of camera, in terms of graphics, you will install the drivers, webcam drivers, audio drivers, graphic drivers. You will install the drivers like same for SQL Server also. Inbuilt Microsoft is going to providing the ODBC drivers. Okay, using that ODBC driver, your relational engine is going to talk with the storage engine. That too, it is talking to the access method. Under the storage engine, there is access method. First, it will talk to the access method. So access method also not having data. But what access method contains? It contains multiple APIs, application programming interface, where SQL can understand. Okay, what sort of request user is requesting? Oh, user is loading the data. User is reading the data. So access method can understand what sort of request we got it from the requester. Now, based on that, access method will send request to the buffer manager. Okay, buffer manager is like a RAM, sir. RAM. Okay, in buffer manager, we are having the buffer pools. In the buffer manager, you are having the buffer pools. Under that buffer pool only, these caches are there. data cache, plan cache, lock cache. There are multiple caches are there. Out of that entire caches, data cache is the most consumer, most culprit, most consumer. This is only the most consumer in the entire cache, data cache. Okay. How I can see that data cache is Subhumis? Okay, there is a clock called SQL buffer pool clock. Normal age, okay, descending. Okay, yeah, this one. Okay, memory clock SQL buffer pool. This is the most consumer. This is nothing but your data caches. If memory is consuming a lot by SQL Server, one and only one clock is the culprit is the SQL buffer pool clock. Nothing but your data cache. 99%, 99% I'm saying SQL buffer pool clock is the most consumer in entire memory because that is only the data cache. That is only the data cache, sir. This data cache. So your access method sends request to the buffer manager. Buffer manager contains the buffer pools. Buffer pool contains the caches. Now first it will go to the data cache to verify for this table, is there any data in the cache? Currently, there is no data. Currently, there is no data. Now, what it will do, being the data is not available, it will go to the disk. It will go to the disk to get the data. It will go to the disk to get the data. Now, under the disk, what is available, Subhum, is databases. Databases. Under the disk, there is a databases. So whenever you create any database in SQL Server, whenever you create any database in SQL Server, by default, you will get two files. By default, you will get two files. What is the two files? .mdf, .ldf. Master data file or primary data file. You can call it as a master data file or primary data file. That is up to you, sir, how you are calling. Some people will call it as a master data file. Some people will call it as a primary data file. Some people will call it as a just a data file. Just it's a data file, sir, where your actual data is storing. Where your actual data is storing under the data file only. So when I go to the physical location, okay, see, this is how it will create the files. Okay, this is our data file. Okay, this is how it will create the file. Under this file only your data is storing. Under this file, your data is storing. So physically, your data is going to store under the data file. Under the data file, physically it is storing. First, it will go to the data file, get the data. What do you mean by get the data? Pages. I will explain in a while, sir. Okay. So get the pages. Okay. And it will place one copy in the data cache. Now same data will send to the requester. So what is happening? First, it will go to the data cache to verify any data is available with respect of this table. If not, go to the disk, get the data, place one copy in the data cache, and send the data to the requester. That is how it is performing for the select statement. That is how it is performing for the select statement. Is it clear, everyone?
Yes, sir.
Okay, this is how your entire actual database architecture, sir. If someone will ask the database architecture, you need to explain very simple. So SQL Server will follow client server architecture. Okay, whenever client send a request, first request will be accessed. Okay, and via SNA protocols, it can be shared memory, it can be TCP IP, and once it go to the relational engine, entire our query will be processed in the relational engine. First, it will check the syntax checks, then it will check the semantic checks, and it will prepare the query tree. That query tree will be stored in the cache. That query tree information will pass to the optimizer. Optimizer will start preparing the execution plan based on the selectivity, based on the cost. Once the plan is prepared, that plan will be stored in the plan cache. Then it will go to the executor. Under entire relational engine, there is no data. Now executor will send a request to the access method via ODBC drivers. Access method can understand whether it is a select statement, whether it is a non-select statement. See, whether it is a retrieval or it is a non-retrieval. So access method contains multiple APIs which can understand by access method. Now access method will send request to the buffer manager. Buffer manager will contain the buffer pools. Under buffer pool, we are having plan cache, data cache, log cache, log cache. Too many caches are there. Out of that, data cache is the most consumer and most usage. You are using most on the data cache only. It will verify any data available respect to that table. If not, get the data from the disk, place one copy, and sends a request to the user. See, this everything is happening via in a fraction of nanoseconds. So it is not taking longer time, sir. To explain this much time is spent, but internally it is just not taking too much time to process all this requests. Nanoseconds only, not even milliseconds. Okay, microseconds. It will do all this stuff in the background. This much things are happening in the background when you are just simply running a query. So when you simply run a query, okay, so I'm just running the query. How many things are happening in the background? These many checks are happening in the background. Is it clear about entire SQL Server architecture? No? Yes? Any questions?
Yes, sir.
Yes.
Okay. Now, okay, fine, Subbu. Now, you need to understand storage, sir, first, basically. Okay. See how storage architecture is working in SQL Server, how storage is happening. See, whenever you are loading a data, especially when you are loading the data, how internally your data is storing. So basically, once you install the SQL Server, is it your job is done? No. You will create the database. Under the database only, your data is actually storing. Database is nothing but collection of your data which is organized, which easily to manipulate, which easily can access, easily to access. Okay, whenever you create a database, data is nothing but collection of data, a specific set of data where you are going to place in the organized format. Okay, but in SQL Server, whenever you create a database, by default, two files will be created. Whenever you create any database, sir, whenever you create any database, by default, it will create two files. Where it will create two files? Wherever you specify the location. So whenever you are installing SQL Server, you will specify where my data files need to go, where my log files need to go. Based on your locations, it will fit. Okay, your database will go to that location only. Okay, so while you are installing SQL Server, you will specify where my data files need to go, where my log files need to go. So under that location only, your data files and log files will fit. So by default, whenever you create any database, there will be two files will be created. One is a data file, one is a log file. One is a data file, one is a log file. So what do you mean by data file, Subbu? Means data files is stores actual data. Whatever you are loading, where it is storing, your data is storing physically on the data file only. Physically, your data is storing on the data files. Okay. Then what about log files, Subbu? Means not only SQL servers, sir, all the database management systems, whenever you are doing any modifications, so no database engine directly writing that modification to the data file. No database management systems are. Now what it is doing, it is writing first into the log files. Maybe the terminologies will be different, but underlying concept will be the same. Okay. Whatever the changes you are doing, all the changes, first it will write into the log file. Then it will write into the data file. Okay. Why it is writing into the log file? Why not in the data file? I will talk in a while, sir. I will talk in a while. Is it possible today? Otherwise, I will talk tomorrow. Why it is not directly writing into the data file? So as of now, what you need to understand, whatever you are making the changes, all the changes, first it will go to the LDF file, then it will go to the MDF file. So if someone is asking what is LDF file, okay, all the change related information, whatever the changes you are doing, all the changes related information, first it will write into the log file before it go to the MDF file. So who is writing that information, when it will write the information, how it is writing the information, in which form it is writing the information, we'll talk maybe tomorrow, sir. As of now, what you need to remember, whenever you create any database, by default, two files will be created. One is a data file, one is a log file. Okay, data file means actual data will be stored in the data file. Log file means all the change related information will be stored in the log file. Then what about NDF file, Subbu? Secondary data files are. See, if you are loading the data, what will happen? The file sizes keep on growing, and it leads your disk will also grow. That leads your disk will also grow. Okay, and if you're loading massive data into the single file, that single file may impact the performance also, because if I wanted to access, if I wanted to load everything, you need to go to this file only, it may impact. Like, see, it's kind of Excel, it's kind of test document, like same, it is a file, sir. Don't think that this is something unique. No. Even you take Excel is also one file. Test document is also one file. Okay. If you're loading massive stuff into the file, what will happen? The file size will be increased. Ultimately, it may impact the performance also. So to improve the performance of your data files, you can create the multiple data files. Okay, you can create one more data file, and you can load the data, different data into the different data files to improve the performance. In that case, you can create the multiple NDF files. Like technically, we are calling it a secondary data file. So it is a secondary data file. Got it? So NDF, MDF. MDF is a primary data file. NDF is a secondary data file. NDF is a secondary data file. Is it clear, everyone? So to improve the performance of data file, you can create multiple NDF files. Multiple NDF files. How to create the NDF files, how to move the data from one data file to another data file. We will talk that also practical, sir. As of now, don't think this stuff. So as of now, what do you need to think? Okay, whenever I create database, there will be two files will be created by default. One is a data file, one is a log file. Data file will contains the actual data. Log file will contains the change related information. Well and good. That's it. Now, okay, fine. Within that data file, how your data is storing. Okay, Subbu, whenever you create a data file, whenever you create a database, two files is creating. Okay, I can accept. Now, within that data file, how data is storing. So within the data file, your data is storing in the form of pages. In the form of pages. Like if you open the Word document. If I simply open the Word document, okay, imagine this is your Word document. Okay, this is your Word document. This is like a page where you are loading the data. In this page, what are all things you can do? When you double click on here, it is a header. It is a footer. This is your actual page. Okay, header. 1 second, sir. Footer. And this is your actual page where you are writing some information. Like same way, SQL Server is also storing your data in the form of pages only. SQL is also storing your data in the form of pages. Okay, in the form of pages. Each page size is 8 kilobytes, 8 KB. Even it is not a 1 MB also, sir. Each page size is 8 KB. Each page size is 8 KB. Okay. Out of that 8 KB, 96 bytes will go for the page header, 2 bytes will go for the page footer, and remaining 8096 something, it will go for the data page, means data pages. This is your data, sir. Data rows, not data pages. Sorry, I'm taking back data rows. Okay. So once your page got completely filled, it will create one more page. Once it got filled, one more page, one more page, one more page, one more page, until that file get full. If you set any restriction, until that it will fill, or until your disk get full, it is creating the pages, loading the data, creating the pages, loading the data. So if someone is asking how data is storing in SQL Server, your answer should be, in SQL Server, data is storing in the form of, hey, come on, yeah.
Pages.
Sorry.
Pages.
Sorry. Not sure. I'm getting sleep. Come on, yeah. Hey. 1 second. Okay, 1 second, sir. Let me call. Can bring the water. I'm getting sleep. 2 minutes. Too much of sleep. Sorry. Okay. See, in SQL Server, data is storing in the form of pages. Each page size is 8 KB, which contains header session, footer session, data rows. A header contains 96 bytes, footer contains 2 bytes, and the remaining data rows will be stored by the remaining size. Now, what information I can see the header means? Header means header contains metadata related to this page. Metadata information means you no need to update anything, sir. SQL Server will update anything. Like what information, which object information it is storing. Okay, object ID, page ID, next page, previous page, and how much page got filled, how much page is free. Okay, how much space is free in the page, how much it got filled, how much size is there, and very important is slots. Very important is slots. Slots is nothing but how many rows are available in this page. Slot is nothing but how many rows are available in this page. Can I read the page, Subbu? Yes, we can read the page. I will show you how to read the page also. Okay. So page header contains metadata information. What do you mean by metadata? Page ID, next page ID, previous page ID, which object, how much free space, how much consumed, what is overall the size, and very important is slots. Slot is nothing but how many records are available in this page. Okay, slots. If you see slot 2 means 2 records are available. If slot is 3 means 3 records are available. That information is storing in the page header. And the page footer is nothing but, technically we will call it as a row offset, sir. Technically we will call it as a row offset. You need to remember these terminologies. We don't have any other choice, sir. Definitely you need to remember this terminologies. Row offset, whenever you are loading the data, it will load this information from the footer only. Okay, so footer contains what record ID it is loading in the space. That information it is storing in the footer. Okay, footer contains row ID information. Which object record is loaded in the space? That page information is storing in the footer. Can I see that, Subbu? No, sir. You can't see footer, but you can see rest of the things. Okay. So that information will be stored in the footer. And this is our actual data rows, like 1 KMS 10,000, 2 MNC 15,000, 3 okay ABC 20,000. This information will be storing in the your data rows. how many records it will store, Subbu. Based on the size of this record, that many records will be fit in this page. That many records will fit in this page. So physically, your data is storing in the form of pages. That pages are available in the data files. It can be MDF, it can be NDF, sir. Not in the log files. Log file, there is no concept called pages. Okay? Log file, that is something different. So log file is something different. So I am discussing only about the data files. Okay? Data file architecture, these are all completely. Is it clear? Any questions? Is it clear? Any questions?
Yes, sir.
Okay, next. Okay. This is little confused, sir, but honestly speaking, don't get confused. Okay. See, whenever you are loading the data, means whenever you are inserting, updating, deleting, or creating, you need, see, for delete, for update, you no need any new pages, right, sir? You remember? See, think as a just a normal person. Data is already available. Within that data you are deleting, within the data you are updating. Do you require any new pages for that one? No, right?
No.
No. Because data is already available, sir. Existing data only you are modifying. Either it is delete, either it is update. So you don't need any pages. For example, you are creating a structure, or you are creating a table, or you are inserting a data. Okay, then definitely you need the pages, correct? Yes or no? When you are creating a table, when you are inserting the data, definitely you need the pages. Okay, that pages directly SQL Server is providing to us? No. Okay, what SQL is doing means first SQL is creating the extent. That extent contains the pages. That pages contains the data set. That's it. So SQL Server is allocating the extents. Okay, extents are nothing but like a pages only. But what is extent means? Extents is nothing but 8 continuous consecutive data pages. Okay, 8 data pages, we'll call it as a data pages. Data pages, we'll call it as a one extent. One extent. So SQL Server is allocating extent. That extent contains 8 pages. Okay, 8 pages. Continuous 8 pages. So first SQL Server is allocating extent. Within that extent, there is a pages. In that pages, you are loading the data. That's it. So SQL Server is not directly creating the pages. SQL Server is creating pages via extents. That extents contains the pages. That pages only were loading the data. So this is only one confuse you are having, sir. Basically. Okay, to simplify, I told in a different way. So whenever you are creating the table, whenever you are inserting the table, so SQL Server is first creating the extents. From that, it is creating the pages. From that, you are loading the data. So you are having two types of extents. One is uniform extents, one is mixed extents. One is uniform extent, one is mixed extents. By default, SQL Server will create the mixed extents only. Okay, by default, SQL Server will create the mixed extents. I am not understanding what is mixed extents, what is uniform extents first. So if that 8 pages contains single object data, if that 8 pages contains single object data, then technically we'll call it as a uniform extent. If that 8 pages contains multiple objects data, okay, see, table 2 data, table 3 data, and index data. So it contains different object data. Then that means we are calling as a mixed extent. We are calling as a mixed extent. If 8 pages contains the single object data, then you should call it as a uniform extent. If 8 pages contains the different object data, then you should call it as a mixed extent. You should call it as a mixed extent. Is it clear, everyone? No?
Yes,
Yes?
sir.
Yes.
Yes.
No. Okay, fine, Zubu. I understood extent. I understood the pages. Now, how many types of pages in SQL Server? Next means we are having 10 types of pages. Out of that, you already know about one page or nothing but data page. Data page is nothing but your physical page where your data is storing. So this is only in this page only your data is storing. Okay, in this page only your data is storing. Actually, your data is storing in the databases. Okay, good. So what about remaining 9 pages, Subbu? Okay, now GAM page, SGAM page, PFS page, DCM page, BCM page, IAM page, boot page, text page, image page. So overall 10 different pages are available in SQL Server. So don't get a little panic whenever you see this much theoretical stuff, okay? I will make you so simplified so you can understand easily, okay? As I told you, data pages are actual page which contains your data. So mainly we'll focus on the data pages. But what about other pages? Each and every page having unique responsibility. They are doing their unique work. So first to understand PFS page. Okay, PFS page. Page free space. Page free space. PFS stands for page free space. So usually every database stores free space information. As I told you, right? Your database contains the page header. In that page header, it is storing the free space information. How much it got allocated, how much free space. Every database is tracking free space information individually. Out of the box, we are having one more page called PFS page. So PFS page is also tracking how many databases having some free space information. Okay, even PFS page is also tracking this database free space information, like in terms of 1 to 50%, 1 to 70%, 1 to 80%, 1 to 100%. 1 to 100% means you completely fill. So what PFS space is tracking? PFS space is tracking free space information about your data pages. Enter your data pages, free space information is going to tracking by the PFS space. So PFS space will track, enter your database usage, means free space information. So how it is going to track? This is how it is going to track. This much. See, for example, from 200 to 250 pages, this much fill. Means from 200 to 250 pages, there is 50 more free spaces there. So that is how it is tracking internally to avoid the confusion. So from 200 to 250 data pages, only 50% free consumed. 50% is a free space. Whenever you are loading the data, it will go to this 200 to 250 pages and try to fit the data in that pages. Fit the data in that pages. That is how it is happening in the background. In the background, that is how it is doing. Now, okay, fine, Subbu. I understand. And this is the first page in the database. Whenever you create any database, what is the first page it will create is the PFS page only. PFS page is the first page. PFS page is the first page which will track all your database free space information. How it is tracking? From these many pages to these many pages, this much filled, this much filled. That means you should understand, okay, 50% is free space. Oh, 30% is free space. 20% is still free space. Oh, completely filled with the data. So first, whenever you are loading the data, first it will go to the PFS space to verify any free pages are available and try to load the data in that PFS space. So try to load the data in the data pages. Once if your PFS space is thinking that all the data pages got consumed, then what it will do, it will go to the GAM page. Global Allocation Map. GAM page stands for Global Allocation Map. So GAM stands for Global Allocation Map, means all your extents. Means Global Allocation Map is nothing but extents. See, Whenever you are creating an object, whenever you are loading the data, you require the pages. That pages are getting from the extents. That extents are getting from the GAM page only, sir. GAM page is your so GAM page is only allocating the extents. Who is going to allocate the extents? Your GAM page is allocating the extents. One GAM page size is 4 GB. One GAM page size is 4 GB. The size of the GAM page is 4 GB, which contains 64,000 extents information. But when I go to the database size, sir, if I go to the database size, my database size is 16 MB. Hey, Subbu, how I can trust you? You are saying that one GAM page size is 4 GB. Then enter my database size is 16 MB only. Come on, yeah. This is the definitely you will get the question when you go for practical. Okay. See, sir, your GAM page size will be grow up to 4 GB. Okay. This is not a static allocation. It is not directly allocating 4 GB to the GAM page once you create a database. No, sir. Okay. Your GAM page will start growing up to 4 GB. It will grow and it contains 64,000 extents information. See, for example, you are creating a table. Create table, employee ID, employee name, employee salary, employee date of joining. You are creating a table. For this table, SQL Server decided to allocate 15 extents. Now what it will do? It will go to the GAM page, get that 15 extents. Okay, out of 64,000 extents, 15 extents has been consumed. Now how many extents it will contains? 63,985 extents are available still. Now it will start consuming. It will reach to 0 extents. Once your GAM page completely fill, again it will create one more GAM page. Okay, that time your database size will also be definitely grow. So it is not a static allocation. It is a dynamic allocation. Is it clear, everyone? No? Yes?
Yes, Subbu.
Yes. Now, one thing you need to remember, sir. Subbu, how SQL Server knows that this extent is consumed, this extent is free? Okay. Internally, SQL Server is tracking in the form of bit 0, 1, 0, 1, 0, 1. Okay. Whenever it allocated the extent, if that extent is free, that will be 1. That extent bit will be the 1. If that extent is consumed, then extent bit will be 0. By using this bit value 0, 1, SQL Server is guessing how many extents are free, how many extents are being allocated. That is how it is calculating. So if someone is asking, what is a GAM? GAM is a global allocation map where extents allocation is happening. By default, every GAM page size will be 4 GB, which contains 64,000 extents information. That's it, sir. Apart from nothing else, you need to remember. Okay, not okay, everyone?
Okay, sir.
Now, SGAM page. Okay. See, if you're simply allocating the extents, now there will be definitely a problem, right? Whether that extent is having free space or not. Who is tracking? SGAM is going to track. See, your page is tracking by the PFS page. Your page is also individually tracking, and the PFS page is also tracking, and extents allocation is also tracking by the GAM page. Extents free space information is also tracking by. See, sir, storage is also very important for us. How RAM is very important, how CPU is very important, how memory is very important, CPU is very important. Storage is also very important, sir. If you are unnecessarily wasting your storage, what will happen? Unnecessarily, your disk is consuming. Again, you need to increase the disk capacities. Your database will grow, disk will grow. You need to purchase a lot of disks, sir. Unnecessarily, you are making burden to your application teams. So for that purpose, what Microsoft is using? Microsoft is tracking the information. Okay, extents are allocating by the GAM pace. Now, whatever the extents are allocated, will that extents having some free space, or that extent is completely filled with the data? So who is going to track? SGAM is going to track that information. SGAM is going to track that information. How it is tracking? If any extents, whatever it is created by this GAM pace, having any free space, okay? If a bit one, the extent is used and as a mixed extent or free space. See, whenever SGAM is making a bit one, then SGAM will think that that extent has been consumed, but it is having some free space. It is having some free space. Okay, that is how SGAM is tracking. Now, if the bit is zero, means the extent is not used or it used and completely filled with the data. Okay, reverse order, sir. This is little reverse order you need to remember. If it is a 1, or X, it is being used but having some free space. If it is a 0, it is not being used or it is completely filled with the data. That is how SGAM is tracking the information. SGAM is tracking the information. So SGAM is tracking GAM pace free space information. PFA space is tracking the page space information. Okay. So these 4 pages are interconnected links are somehow allocating, tracking, allocating, tracking, allocating, tracking. So today I am not discussing about the DCM piece. Okay. And I am not talking about BCM piece, IAM piece also today. Okay. These 3 pages I will talk. This page I will talk when we are discussing backup. This page I will talk when we are discussing recovery model. This page I will talk when we are discussing on an index. As of now, just remember DCM page, BCM page, IAM page. Whenever we are discussing the respective concept, I will talk about these pages. As of now, you no need to think about these pages because you already overloading. I don't want to make too overload because these pages are something very interesting pages, very important pages in terms of theoretical, in terms of little practical. In terms of interview, this is very important, sir. Practical, we won't go this much deeper in the real world, but understanding level very important. Interview point of view is also very, very important. Not on practical that much. Mostly we won't do this much, sir. It's a default behaviors. We no need to touch the default behaviors basically. Okay, so IAM page, BCM page, DCM page, I will talk separate concept, and boot page. This is our 9th page, sir. Whenever you create any database, the first page will be the database, PFS page. Second page is the SGAM page. Third page is the GAM page. Fourth page is the database. And some of the internal pages will be created. And the 9th page will be the your boot page. Boot page. Okay. What do you mean by boot page, Subbu? Means every database, whenever you are creating the database, by default there will be MDF file. Okay, and you can also create the NDF files and there will be LDF files also. Only on MDF file the boot page will be created. Okay, boot page is contains the metadata related to your database. I am not understanding, Subbu, what do you mean by metadata? So your DBID, database name, database files, when was the last checkpoint got triggered, when was the last, what was the last LSN number moved, everything it is going to track. Metadata, this is not a data. This is system related information it is tracking. So 9th page is your boot page. That boot page is available only under MDF file. That boot page is available only in the MDF file. To show you uh, last 3 BCC, okay, known good. If I wanted to read this one, boot page, if I wanted to read the boot page, this is the simple command, sir. This is the simple command. Okay. 2010. I need to pass the database name 2010. Yes. So whenever you run this command, you are getting the metadata. See, you are getting the database version when you created, okay, DBID, compatibility level, okay, LSN details, checkpoint LSN details, okay, last log backup details. So, and one more very important point here is, when was your last DBCC check DB happened? This is something very important. So all the metadata related to your database will be stored in the boot page. So this boot page is available only in the MDF file, and this is our 9th page. This is our 9th page, and it will be available in only in the wait, sir, in the MDF file, not in anywhere, not in anywhere, sir, not in anywhere. This will be available only in the MDF file, boot page, and remaining test and image page, sir. Whenever you are loading the documents, that data will be stored in the text pages. When you are loading the images, that data will be stored in the image pages. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are overall 10 pages are available. Each page is doing respective work. Each page is doing respective work. Is it clear? Not clear, everyone?
Clear, sir.
Yeah.
But definitely will get one doubt, sir. Okay. Subbu, is it possible? Can you show me how DCM page, GAM page will looks like? How SGAM page will look like? Is it possible to show us? Yes, sir. I can show you that stuff. Okay. So if I see, these are all undocumented comments, sir. Please don't trigger in the real world. Of course, it won't impact anything. Of course, it's not impacting anything. Nothing but okay, boot page. Okay. So if we wanted to read the page, okay, you need to enable the trace file 3604 dbcc trace on, and there is a command called dbcc page. See, sir, when you go to the here and when you search in the Google, okay, there is no block called len.microsoft.com. See, whenever I go for any other command, there is a block called len.microsoft.com. But when you go for the page, okay, there is no block called len.microsoft.com. This is unofficial command, sir. Undocumented command. Technical is to say undocumented commands. Will it impacting anything, Subbu? No, but it is violating the behavior, because I can read the pages. I can go to the page. I can read the page what data is available. So it is kind of little not secured. So that's the reason Microsoft is treat like this is undocumented commands. Try to avoid to run this command in the real world. Okay, whenever you really need. What do you mean by really need, Subbu? Is, for example, your database got crashed, and when you were troubleshooting, you came to know so and so table got crashed, and you came to know so and so page got crashed. That time, these commands will help us a lot. What is available in the page, what data may be lost. If I want to do deep dive that way, that time you can run this command. Otherwise, try to avoid to run these commands. It will mislead us basically. Okay. Now you need to pass the database name. As I told you, okay, as I told you, this is your file ID. What are the parameters? This is your database name. This is your file ID. This is your page ID. This is your mode, sir. Mode. Okay, what mode I can display? So I told you, right? PFI space is the first page. PFI space is the first page. So that is the reason I am running one here. Okay, when you run this command, it will display the PFI space information. Okay, I told you, right? There will be buffer. Every page contains the buffer information. Okay, this is your page, file ID, page ID. and every page contains the metadata buffer information. I told you that there is a buffer information header. You remember I told you there is a header session. Header m type equal to 11, sir. Whenever you see that m type equal to 11, it is a PFS page. Whenever you tell m type equal to 11, that is a PFS page. I told you, right, how much free space is available, how many slots are available, what is the previous page, what is the next page, which object information it is storing, what is the page related information, everything it will store under the header. And if you scroll down, now you are getting, say, 0 to 3 pages, 100% full. 4 to 5 pages, not at got allocated. Okay, 1 to 6 pages, 100% is full. 8th page, 0% free. 9th page, it got full. So it is telling which pages got full, which pages got free. And based on that, it is allocating, sir. You won't go and do all this stuff in the real world. But if I wanted to see, you can see. There is a IM page is also created. And it is a mixed extents. It is a mixed, this page is belong to mixed extent. It is showing that information. If scroll down, you will see massive information. Okay, scroll down. Okay, one PFS page is almost like a kind of 8,088 pages information will be stored. How many pages, sir? 8,088 pages information will be stored. 8,088 pages information will be stored. After 8,088 pages, again it will create one more PFS page. After again 8,088 pages fill, again it will create one more PFS page. Every 8,088 pages, it is creating one more page PFS page to track the page free space information. Got it? No? Yes, everyone?
Yes, sir.
Oh, I will share one document, sir, all this stuff. Okay, you can refer that document easily to understand. Okay.
Okay.
All these comments also I will mention, sir. You don't need to worry about the Susugo. I'm missing the comments. No, I will mention the comments also. Now, if I wanted to get the SCAM base, SCAM, this is our second page, right? So just change the 2 and run the query. Okay. See, this page will also contain the buffer. This page will also contain the header. And whenever you see the M slot equal to 8, that is the SGAM page. Will I need to remember all this stuff? No, sir. Please remember only one thing, how to read the page with help of this trace file 3604 and with the help of DBCC page, I can read the page. And at the header, what information? File ID, page ID, next page, previous page, how much free space, how much got allocated. Okay, everything you will get. That information, just remember. Rest of the things, no need to remember anything. Okay, rest of the things, you no need to remember anything. So if you scroll down, so from this section to this section it got allocated, and from this section it's not allocated. From this section to this section it got allocated. From this section is not allocated. From here to here it got allocated, not allocated. So SGAM page will contains extents allocation, deallocation information. It is going to track internally. It is going to track this sort of information. This sort of information is tracking. Like say, if I go for 3 means, that is a GAM page, global allocation map. Okay, so whenever global allocation map, you see the M type equal to 9, and here also same thing. How many extents got allocated? So how many extents got allocated? How many extents got deallocated? What are the things are happening in the background, sir? In the background. I think 5 lakhs, after 5 lakhs, these many pages, next GAM page will be, let me calculate, sir, to show you in terms of calculation. 64,000 extents, right? Each extents contain 8 pages into 8. Okay, yeah. After these many pages, there will be one more GAM page will be created. After these many pages created and all these pages got allocated, then next GAM page will be created after this. After this, next GAM page will be created. This is how you can read the pages. And will I do this stuff in the real world, Subhamis? No, sir. Honestly, no. Okay? Not okay, everyone?
Okay.
So the middle one is pages, and number one means
1 means, okay, PFS page. 2 means SGAM page. 3
yes.
means GAM page. If you wanted to read the database, you need to get the database ID, sir. Okay? In upcoming days, I will show that demo when I try to load the data. Okay? How to read the database, Subbu, I will show you when I'm reading. I will show you that.
Okay. So I'm asking about that first one and last one, number one and number three.
Oh, number one is a file ID, sir. What do you mean by file ID? Means whenever you see sp_help db, okay, and you wanted to read this information, okay, see there is a file ID. So whenever you create a database, there will be one MDF, LDF, right? So I am not worrying about log file, sir. I am worrying about data file. So if you are having only one data file, the file ID will be 1. If you are having one more file ID, the file ID will be 2, 3, 4, 5. Which file, which page you are reading, that you need to specify here. Got you, everyone?
Okay. And the last one?
It's a mode, sir. Mode, display mode. We'll use 3 default. Okay.
Okay.
Sometimes I too will confuse with this values because whenever I am taking the sessions, only I will run these comments. Otherwise, I never run, sir. This is, I told you, right? Undocumented comments. Please don't try to run in the real world. Please, sir. Please. This is my request. Okay. Yeah, that's it for today. Hope you understand very well. No? Yes?
Yes, sir.
Let me save, sir. SQL Server Inter. Let me save this one somewhere. Device. Okay. Somewhere I created the folder. Okay. I hope. Thank you, sir. See you tomorrow. Don't miss tomorrow. This tomorrow is also very, very important. Okay. All
Subbu,
seasons are
one
very
last doubt.
Yes, sir. No, you should not ask. You can ask any number of doubts. Okay.
So how do we find out the SQL handle for a query?
Oh, I told you, right? There is a DMV. Using this DMV, I will get to know. So when you simply run, there are nothings are here. Okay, when you run this query, it will tell us what query you executed. Okay, so what query you executed for that query? What is the SQL handler? What is the plan handler created? Now,
So
by running these queries only, we will get to know the information.
Yeah. So I understand, but is query will be shown beside that SQL handle? That is what I'm asking.
Oh yeah, when you run this one, okay. Thing is why it is see. Now this menu so far, see, after you reboot the server, okay, this is something very important. After you reboot the server, your cache, whatever you are running, everything will be caching, right? Yes or no?
Yeah.
Caching. It is getting from the caching only. Now, under the present caching, this information is available. So this query you triggered, for this query, this is a plan. But you can't read this SQL handler, sir. If I wanted to read, I need to pass this into the this DMV. Select star from sys dot dm underscore exec underscore exec underscore SQL underscore text. Now I will pass the SQL handler. Come on. I will pass the SQL handler here. So when I run this query, you will get the SQL script. Okay, you will get the SQL script, sir. So nothing here, nothing we done at this randomly. So that's the reason it is not displaying, but you will get the SQL script. So usually you won't run individually, sir. You will run like this. Okay, when you combinedly run all this stuff, okay, you will get to know the information, because just now I restarted SQL, right? After that I not done anything. That's the reason you are not finding anything, sir. Otherwise it will display the query, everything it will display. It will display the SQL handler, plan handler, everything it will display. I will show you, sir. No worries. Okay.
Thank you so much.
Yeah. Thank you. I will share one document today. Please refer the document. By evening, you will get the document. It contains architecture details, whatever we discuss, that details in depth. Okay. You can practice. You can learn. Okay. Thank you. See you tomorrow.